Hi, I'm Julian. I'm the OpenLineage project lead, and today I'm here to mostly listen in and catch up on things.
Thank you. Next, Ernie.
Hi, Ernie Ostick with Manta, now an IBM company. I'm part of our product team and working on our OpenLineage integrations.
Thank you, Damien.
Hi, I'm Damien. I'm a software engineer at Booking.com, contributing to the OpenLineage Spark integrations, particularly as we are currently integrating OpenLineage into our data analytics platform environment.
Yeah, we're going to hear more about your recent work in Spark in just a few minutes, which is really exciting. Thank you. Shiri?
Hi, I'm Shiri Cabral. I'm a product manager at Calibra for Lineage from ETL Tools.
Thank you. And we're going to be sharing news about an event that we're working on together in a few minutes as well, which is great. Thanks, Maciej.
Hey, I'm Maciej. I'm a software engineer at Getting Data and OpenLineage committer. I don't have anything today.
Thanks. Tia?
Hi everyone. I'm Mattia, software engineer at Booking. I'm working with Damien to integrate OpenLineage in our infrastructure.
Which is great to see. Thank you. Next is Jens.
Yeah, hey there. I'm Jens, engineering manager at Google. We are building the Lineage capability for Dataplex and BigQuery, and I have a colleague here with me.
Yeah, hi, I'm Mary. I'm a software engineer in Dataplex Lineage.
Thank you. Great to have you both. Paweł?
Hello, I'm Paweł. I'm software engineer at Getting Data and Astronomer. And I would like to tell you a few words about the circuit breaker feature that I was working on recently.
One of just a few big projects that Paweł's been working on. We're looking forward to hearing more about that in a few minutes today. And I believe last but not least is Harel.
Hello, everyone. I'm an engineering manager at Datadog working on data lineage. Glad to see everyone.
Cool. All right. Thank you. I'll share my screen and we can get started. I'll also start recording.
There is one thing though, Michael, you probably need to introduce yourself. You're the only one left out.
Do I? Yeah, a community manager on the project and here to share some exciting news and some release highlights. So let's see here. I think I need someone to help me with the recording. I might not be technically the owner of the meeting.
I think it's already started.
Yes, the recording is started. It's in the LFX account.
Okay.
So you can just go ahead and share.
You'll see there's a pretty exciting preface to the meeting talking about physics and relativity.
All right, so more about that expanded committer list in just a second. Here are our communication channels. Note our new LinkedIn company page. If you haven't joined the company page, it would help us a little bit. We get more metrics from LinkedIn that way. On the agenda today, we're going to look at the recent very large 1.9.1 release. We're going to hear about the addition of Scala 2.13 support and Spark from Damien. The circuit breaker that Paweł mentioned, we're going to hear a little bit about that, followed by discussion items and open discussion, as well as some announcements. So on the subject of committers, wanted to thank Peter Huang, and thank him for all his contributions and welcome him as a committer to the project. As Julian said in his nomination, his main contributions have been on the Flink integration, and he's done some help behind the scenes to get the Flink community to adopt the dataset model and influence their Lineage API. So thank you so much, Peter. Welcome and congratulations. Okay, so I teased the news. Just this month, we've heard news of 2 new integrations in the ecosystem. So don't have too much detail to share yet about one of them. Hope to learn more, but we can share we've learned that OpenMetadata and DataHub have merged integrations. And from PRs, we've been able to identify that in the case of the OpenMetadata connector, they're emitting lineage information to a Kafka topic, or this is for users who want to do that. And it can allow users to store metadata within projects. Maybe they want to enrich that with lineage information collected using OpenLineage. So those are the features there. Hope to learn more about that. Does anyone on the call, anybody on the call have some more information about that at this time?
I know a guy who may have worked on that, and I can ask if they want to share more on the next meeting.
Good. That would be great.
And Natalie from Natural Intelligence said that they would test out their integration and try to switch to this to see and give feedback.
Okay, thank you. And the other one we heard about recently is an integration in DataHub. This is apparently a new endpoint, a new backend, and a Spark Lineage beta plugin. The PR itself has no description. So hope to get more information about that soon. In events, we have a meetup coming up on March 19th in Boston at Microsoft New England, as I mentioned, co-sponsored by Calibra. Want to thank Shiri for doing a lot of the logistics and helping with the space. That'll be at 5:30. Unfortunately, RSVPs are closed. If you're in the Boston area and you really want to come, we might be able to squeeze you in, I think. Shiri?
Yeah, it's the RSVPs are closed because we were told by Microsoft that we need to have the list of people who are coming by yesterday, like a week ahead of time. It used to be 2 days ahead of time. I haven't been there recently, so I don't know. Like, do they need you to show your ID at the door? And all we had was names of people that they use on Meetup. So if someone's name was Mike on Meetup and we didn't have a last name, their name is Mike. So if there is somebody who is like super interested, you can RSVP for the event, contact one of us, and we'll try to see, if the day of, if it's something that we can get you into.
Thank you. Yeah. So looking forward to that. Also, Paweł and Maciej are speaking at Kafka Summit. Also on the 19th, their talk is called OpenLineage for Stream Processing. So thank you for spreading the word about OpenLineage. It's exciting. There's a panel coming up at Data Council moderated by Julian, Eric Veliker, Shiri, Ernie, and Harel are participating, and that's called We've Come a Long Way. That'll be on the 27th at 10:45. So thank you all for also sharing the news about OpenLineage. Also, coming up in April, have a panel. This was led by Accenture, so co-sponsored with Confluent. It's called Open Standards for Data Lineage. Going to be exploring data lineage's future. That will be at 4 p.m. GMT, 10 a.m. Pacific time. Julian, Kai from Confluent, Mandy, Jens, Ernie, Shiri, and Austin from Atlin. That's moderated by their data streaming lead, Luigi Scorzato. More info at events.confluent.io. Okay, have a recent release to talk about. We're going to hear more about a couple here, so I won't go too in depth. But had a lot in this release. By lines of code, it might be the largest release ever in project history, as a matter of fact. And significant additions to multiple integrations here. Lot of contributions from various people. So just wanted to spend a minute here talking about some of these additions. In 24/17, we added support for Flink Kafka tables, getting the topic and the schema. And also in Flink, added support for the multi-topic Kafka syncs in the Flink integration. Limitation you should be aware of there, the record serializer needs to implement the Kafka topics descriptor. So see the docs for that. In Flink, we added support for lineage from JDBC connectors. And in Spark, the event model formerly described only single actions. And now, thanks to 2371, it emits intermediate application level events, running the entire job. In multiple integrations, Airflow, DBT, and Spark, we've got support for the job type job facet now, thanks to Mattia's work. And then last but certainly not least, I think in the neighborhood of 11 PRs altogether, you factor in the testing and all the config and, really big lift. So thank you, Damien, for 2446 and the other PRs that went into adding support for Scala 2.13. That in a minute. So thank you to all the contributors, and I'll hand it off to the next speaker, and that is Damien. So let me, would you like to continue?
Yeah, so I have the slides already in the slideshow, so you can carry on driving the slide, or I can present, not a problem.
Okay, I'll carry on. Okay.
Yeah, so I'll just give you points next slide and whatnot. Yeah, so everybody's able to read slides, so I'm not gonna talk over slides, I'm just gonna give some highlights. So Apache Spark, originally compiled with 2.11, before version 2.4. Then they decided to start releasing 2.12 variants, and these carried on until about 3.2, at which stage they were like, okay, fine, we're going to produce 2.12 variants and 2.13 variants. Right now, they still produce 2.12 and 2.13 variants. So those of you that have ever worked with Scala know its infamous binary incompatibility problem between major versions. So like 2.11 cannot work with binaries compiled with 2.12 or 2.13, etc. And the reverse is also true. There's no sense of backwards compatibility either. It's basically you compile code with 2.11 and you need other binaries that were compiled with 2.11 if you want your code to carry on running. Now, this for someone writing Java, this isn't really a problem. Because we don't care about Scala's binary incompatibility. We just give me the code, give me the type signatures, and I can work with it. However, as you're soon to find out, can you go to the next slide? There was the Scala language maintainers did something with 2.13, right? And this was specifically, they made a change to the collections API. So this isn't a binary compatibility problem. This is a type change problem, right? So in Scala 2.12, they had a type called a sequence, right? Or SEQ for short, but I will carry on saying sequence. And its full name was scala.collection.sequence. In Scala 2.13, they changed this name. Well, more specifically, what they did is when a Scala developer writes the word sequence in their code, the Scala compiler would insert Scala.collection sequence in 2.12 and earlier versions. When it came to 2.13, the sequence was essentially changed to reflect as Scala collection.immutable.sequence. Now, this is a problem, mostly around method signatures in the JVM, right? Because the JVM needs to know the identity of a method, and an identity of method is given by the return type, the name, and then the input types, right? So if one of these things doesn't match and it cannot find it, the JVM throws the infamous no such method error, right? Which will just, for all intents and purposes, tear down your application as what happened to us when we were like, yo, we've got OpenLineage Spark, let's go. And our sister teams didn't tell us Scala 2.13 that they're using, or they're using Scala 2.13 variants of Apache Spark. And so, yeah, we were scrambling there, trying to understand what actually happened. Next slide. So this is just some code snippets of simplified code snippets, right? So in the top, you see trait something with def data sequence int, right? So that's Scala, right? This is what a Scala developer sees. This is what they write. When the Scala compiler runs, right, it generates something that looks on the right. This is a general simplification because there are other things that, for all intents and purposes, we don't need to get into, right? But you can see it puts the fully qualified type name as the return type there. So Scala.collection.sequence. Note, this is for Scala 2.12 or earlier. Now we can use this compiled code, right, in Java, which is the snippet at the bottom, right? And we're quite happy to consume it. It's a bit awkward for a Java developer to consume Scala code, but hey, we can live with it. Next slide, please. Right, so now comes Scala 2.13, and the Scala compiler does the same thing, except if you contrast the bit on the right with the previous slide, you will notice that there is a slight change in the type signature. Namely, it's now Scala.collection.immutable sequence. Recall, the JVM uses three things to identify a method: the name, the return type, and the input types. The fact that this return type has changed in the eyes of the JVM, but not necessarily the eyes of the programmer, right, means we will get a no such method error. Right, next slide. And so you have this Java code. It expects something on the left, but it's now getting something on the right. And this is what causes that no such method error. So next slide. So how do we go about solving this? Well, it's a complex problem, first and foremost, right? And the complexity has to live somewhere. There was a lot of back and forth, particularly in my own mind, of which approach I should take. But I tend to value compile time safety over anything else. And for this reason, I chose to go down the route of moving the complexity to the build system. Right. What this meant is I mostly didn't need to touch any code. Right. There were some places where we did have to touch code, specifically when it came to the conversions from a Scala collection to a Java collection. But for all intents and purposes, the code remained largely the same. The only difference is now the CI/CD process had to be expanded to include 2.13 variants. The publishing process had to be expanded to include 2.13 variants. And the entire Gradle build mechanism had to be able to handle this switching, right? And this is controlled via parameters that are supplied at runtime. Other options were using so-called reflection. Reflection is all good and nice, really easy to use. However, it is notoriously slow. When I say notoriously slow, I'm talking in orders of magnitude slower than regular Java code. And in a tight loop, this can be a significant performance detriment. It also means that you don't have compile time safety anymore. You now need to write unit tests to validate that what you wrote is actually going to run correctly. Java, I believe 7, maybe Java 8, introduced the concept of method handles. Method handles are a really nice way of writing reflection code, or sort of reflection code, but it's more strongly typed than regular reflection. It's also significantly quicker in terms of its runtime. It's almost as fast as writing or using regular code. The downside there again is it's still runtime checking based, right? I still have to write unit tests to be able to do this. Another option which I immediately dismissed when I thought of it was bytecode weaving. This is when you get the Java compiler to compile your code, and then you go and inspect the bytecode afterward and manipulate it there. That requires expertise on all the bytecode operations, and you have to be aware of it. It's almost like assembly language in that it's a stack-based thing, so you need to know the order of operations that you need to put things in. Otherwise, you will experience wonderful runtime errors that would probably like throw you for a loop, and you'd be really confused. Next slide. Right. So the result. Well, as I said, we published. We now have support for Scala 2.12 and 2.13. This necessitated us having to publish 2 artifacts, right? And there's a little picture at the bottom there that shows, hey, on Maven repository, we now have a Scala 2.12 and Scala 2.13 variant of the OpenLineage Spark integration. And that's pretty much it, right? Like it was quite a long lead up as we had to go through a process of modifying each individual module within the Spark integration to say, examine, does the thing support Scala 2.13 or not? And if it does, well, we need you to compile against the Scala 2.12 binaries and the Scala 2.13 binaries simultaneously. Well, sort of simultaneously, obviously just in different build processes, but that capability had to be inserted into the build process. Yeah, that's it for me.
Thank you so much, and thank you for all the work you put into this contribution. Are there any questions for Damien?
Thanks for all that work. It was
You're welcome.
a lot of great PRs.
So what's next, Damien?
Right now for us actually is we are taking this 2.13 library and we are testing it in the previously aforementioned environment where it blew up. And so far, so good. The data that's coming out, well, for one, it works, and the data that comes out looks good so far.
Awesome. Okay. So next on the agenda is Paweł. Would you like me to keep control of the slide deck, or do you want?
No, I can share the screen because I would like to show some code and documentation. And yeah, I was able to read Damien's PRs and they were amazing. It's really brilliant piece of work. Damien, Mattia, thank you for bringing this. Yeah, so I can't imagine anyone else being thrown into this massive amount of work. So really appreciate it. Okay, let's share the screen. I hope you can share the screen. You can see the screen in a second. Do you? I bet you do. So it's the circuit breaker slide, and yeah, and this is kind of the long-awaited feature. So users would love to turn on OpenLineage at scale at several Spark jobs at once, and yeah, they want to be sure they are not breaking things. They are not breaking the existing jobs. Yeah. So I imagine it as an ops team trying to turn it on for the data teams, and yeah, the data teams are asking, "Hey, are you sure it will not break the things?" And yeah, up until circuit breaker feature, the answer was, "Yeah, we bet it will not break things that much." But there's a certain risk. So imagine a job utilizes almost all the memory resources it has assigned, and surely OpenLineage has some footprint on the memory and CPU. And the risk is that, you know, you can use too much of the resources. And yeah, can you prove that turning OpenLineage on will not result in a problem and job failed? And actually, the circuit breaker feature is something that says, yes, we can make sure of this because we run all the code within the context of circuit breaker that checks if we have enough CPU, if we have enough memory, and if we don't, it turns OpenLineage off. So there's no risk that something will do damage to your job. So the circuit breakers were implemented within the OpenLineage Java, so the Java client, but they are also available out of the box for Flink and Spark. Within the OpenLineage Java, it makes sense to run them in the context of emitting an event. For Flink and Spark integration, it makes more sense to verify the behavior the moment the event is populated and built to make sure that, when we traverse the logical plans, we don't mess up with memory and resources. There are different circuit breakers implemented within the PR. Some of them which are not covered in the doc are, let's say, the internal ones, like the no-op circuit breaker. So the circuit breaker that always runs, is never closed. And the static one that was just used for the testing purpose. So it can be defined that it's open for 2 method calls and then it's closed, so that we can see the behavior. In general, the idea can be explained based on this method. So it's part of the circuit breaker that gets a callable as an argument, and it starts 2 separate threads. One thread would just run the callable, while the other one will run the circuit breaker. And every time interval that can be configured, like every 100 milliseconds, it will see if the circuit breaker is still open or closed based on the implementation of the circuit breaker. So, you run your casual integration and in a separate thread, check every 100 milliseconds, is everything okay so far? Is everything okay so far? If not, you close both threads and so you lose the lineage, but the job is up and running still. So in case of the no-op circuit breaker, there are no 2 separate threads. It's just a single method call here. So if you don't configure circuit breaker, nothing will change for you. You don't have to be worried about this. And we developed 2 reasonable circuit breakers. First one is the simple memory circuit breaker that just checks on the amount of memory being used. And it was a suggestion from our users that, hey, it will be useful to have something like this. And the user has implemented it in his environment. So they claimed it's solving the problem. So we implemented this one, but then realized that perhaps simple memory check is not enough because your Java job can utilize a lot of memory, but as long as garbage collection is quick, it shouldn't be considered a problem. So then we looked into some, I think it was from the New Relic. They have the Java circuit breakers for the New Relic agents, and it was open source. And their implementation was based on the combination of the memory footprint and the time spent on garbage collection. And this led us to something we call a Java runtime circuit breaker that based on those 2 factors decides if it is still closed, the circuit breaker is still closed or no. So, even if you utilize a lot of memory, but the garbage collection goes smoothly, so the percentage of time spent on old gen garbage collection is low, everything is fine. But if those 2 factors are above the threshold, then let's close the circuit breaker. And this is something we did. And then at the end of PR, of course, Maciej was a great reviewer as always. And at the end of PR, we had like a discussion about how to document it. So I don't know if you remember it, but some time ago, the Spark integration documentation was put all into the README file. And we had like 2 worlds, the README file and the OpenLineage.io documentation. And some contributors preferred the one, some the other one. And there was no single source of the truth for determining where shall I look for the certain features. So yeah, at the end of this feature, we decided to do some massive refactor of the documentation, and yeah, which resulted in getting rid of anything within the README. So the README should not be considered as a documentation, and all the content from the README that was not present within the OpenLineage.io documentation was moved there, like the extending documentation, so documentation on how to extend Spark integration. Then there was another problem within the documentation. So like we had some features described in several places. So imagine things like the transport. So OpenLineage transport in the Java world that works for Java client, Spark integration, and Flink integration. So actually it's the same mechanics, it's the same configuration patterns. It's just that it's configured, it's documented in different locations. And well, it didn't make sense for Spark users to tell them, hey, you need to read Java client documentation first, because no one will read it. So we decided to go with kind of README markdown partials. So the markdown files that are reused among the documentation pages. And if you see the client library, the Java configuration, and the transport section, it's the same markdown file that is used here on this page, and it's also used within the Spark configuration, and the same page, the same file in the repo is used for Flink. So if someone is developing a new transport feature, he or she just needs to, put the doc in the new, in a single place. We do have 3 tabs. One is for YAML config, because the configuration can be provided by putting the YAML file along with the job. Spark config for the Spark config parameters, or the Flink config. It's actually copy paste of the Spark config. It's just there is no Spark dot prefix. Yes, so based on that, we put everything into the OpenLineage.io page. And if you are interested more about the circuit breaker, that was my initial topic to discuss, you can see the documentation, and it's now up to date. And I hope it will stay up to date for a long time, because it's documented in a single place. And yeah, if you have any questions to either circuit breaker or the documentation, please don't hesitate to ask.
I just want to say it's already useful for me. It prevented the one Spark job from running out of memory. So like it.
Yeah, I'm happy to hear this. There was some guy in the past who tried to implement the timeout feature. So if the OpenLineage integration takes too long, let's turn it off. And actually, we didn't hear from him for some time. And he started a PR, which seemed to be quite complex. But now it's going to be a way easier, because I think I told you, I showed you this method. It's like starting 2 threads. You just need to check if you didn't exceed a timeout in a single method. So yeah, if someone wants to take it over, I believe it's a great feature for the users, and it just lines of the code to be done.
Thank you so much. And in particular, I just want to say thanks for the documentation upgrades. I think it's going to make a big difference for users, and the removal of duplication and conflicts across the repo and the docs, really big. So thank you. And, as we get more users, which we are, I'm looking at some of the numbers, we're seeing big increases in our activity on Slack and GitHub. just in the recent months. So this will make a big difference as new people come on board. Okay, so our next topic on the agenda is discussion items. I don't think we have any on the slides, so don't need to open up the slide deck and just see if there are any discussion items from folks on the call. Topics you want to bring up today?
So I created an AAP for Airflow that enables it to get lineage from hook instrumentation. And if anyone's interested in Airflow and or getting lineage from Airflow, then I recommend taking a look and commenting. Feedback is always welcome.
That's awesome.